Okay, so we are going to be graphing y equals sine x today. And the input, what is it when I say sine of x? What does x represent? What do we do? Sine of a angle. Thank you. Sine of an angle is always an angle. So our input is the angle. Yes, Rachel? How do I skip all these? No, that's fine. I'm just like, how do I skip all these people? That's what I'm trying to figure out. Here. Oh. Sine of an angle. So we're inputting an angle. And when we get out, our output is the sine at that angle. So everybody remember that sine is y. So if I talk about 0 degrees, what is my y value at 0? 0. So we're thinking about those triangles or that ordered pair. And then at pi over 6, what's the sine of pi over 6? Oh gosh, what is pi over 6? 30 degrees. What's sine 30 degrees? Now, on this unit circle, to get to pi over 6, we go over x and then we go up a half. So the y value is the blue line that I just drew. And then at pi over 4, what's the sine? It's radical 2 over 2. So the blue line that I'm drawing is the length of the y value at that ordered pair. The y value at pi over 3, the sine of pi over 3, is radical 3 over 2, so there's the length of that. And then at pi over 2, the length is 1. So what can you summarize about the length of the y's as the angles are getting bigger? What's the length doing? They're getting longer, they're getting bigger. And once we go past pi over 2, now if we look at my y value lengths, they're getting smaller. And they reflect or they're the exact same as the ones in the first quadrant. They're also positive, they're just going back down. So radical 3 over 2, then radical 2 over 2, then a half, then 0. So I'm just looking at how long these blue lines are. And then when we go past pi, now what happens to this y value? It's the same as the value above it, except what? It's negative now. It goes down a half. It's still a half long, it just goes down. And then we've got down, radical 2 over 2. And then down, radical 3 over 2. And then down, 1. And then once we go down 1, that's the longest negative y value. And then it starts going back up again. It's still negative, but it's getting less and less negative. Until we get to 0. But when we go in circles, we don't just stop. We can go on forever as many times as we want over and over again. So this is what's called periodic, where there is one full cycle, and then that cycle repeats itself. Repeats. What's the duration of one cycle? How long does it last? 2 pi. Exactly, 2 pi. That's called, what's the period? 2 pi. One cycle is the period, 2 pi. All the way around once, 2 pi. Okay? So that's sine. Flip it over, we'll look at cosine. So cosine is the, not the y, what is it? Yes value. So now we're going to look at the horizontal at each of these angles. So at 0, my horizontal length is 1. At pi over 6, this cosine at pi over 6 is radical 3 over 2. At pi over 4 is radical 2 over 2. At pi over 3 is a half. And then the cosine of pi over 2 is 0. So what's happening to my x values as the angle gets bigger? What's happening to my x values? They're decreasing. They're getting shorter until we get to 0. And then what happens after we go to 0? We go to 2 pi over 3. What happens to my x value now? What page? It's negative now, but it's going to be the same as the one right across from it, so negative a half. And then Bain said it's increasing. It's increasing, but it's getting more negative, right? So negative radical 2 over 2, negative radical 3 over 2, and then negative 1 is the longest cosine value given at this. And then from there, we're getting less negative. We're still negative, but we're getting less negative. And so we get to 3 pi over 2, we're at 0. But I haven't finished my circle yet. So after 3 pi over 2, now the x values go back to positive. And they're getting bigger until we get to 1, and then they get smaller again until we get to 0, then they go more negative until we get to negative 1, and we continue this pattern. And all of these numbers on both circles are the same for sine and cosine. They're just like kind of starting at a different place. But they're all the same numbers. We're good? Next page. So now what we're going to do is we're going to take, we'll do that in a moment. Before I get to what we're going to do with that, this is thrown in here because we're going to do transformations. If you forget where the number is added or subtracted or negative or multiplied, this is just a summary of the stuff we did in chapter 1. And then at the bottom, this is the kind of information you'd find in a pre-calc book. But I actually I'm not going to do it that way. I'm going to do it using transformations, and I think it makes more sense that way. But you'll find out as I talk. This is all reference material if you need it. So now, the back of that second page, that's where we're going to go. So we're going to graph the parent function. These are the parent functions for sine x, and at the bottom we'll do cosine x. So sine x. You can use whatever x's you want, but accepted values, the ones that everybody uses, are the easiest ones. Not even 30 degrees, though. Not even 30 degrees. Which values are we using when you look at 0, pi over 2, pi, 3 pi over 2, 2 pi? Which values are we using? We're using the ones that are actually on the axes. And 0, pi over 2, pi, 3 pi over 2, and then 2 pi again. So it actually makes one complete circle. So this here is one cycle, or one period of the graph. So now what we need to know is sine is y. So on this graph down here, what is the value of y at 0 degrees, or at 0 radians? 0. At pi over 2, 1. At pi, 0. 3 pi over 2, negative 1. 2 pi, 0. And then it's going to continue to repeat over and over again. So we will plot those ordered pairs on the graph, and I apologize before you start plotting them. I copied the wrong graph. I've got to change that for next year. I don't know what happened. I copied ones that have pi over 3s in them instead of pi over 2s. So you can see pi is here. So pi over and 0 is here. So pi over 2 is right exactly in the middle. All right. So 0, 0. Pi over 2 is 1. Pi is 0. 3 pi over 2 is negative 1. And 2 pi is 0. And then when we connect these, they are smooth curves. They are not zigzags. They're beautiful, smooth curves. So I have graphed one cycle, one period, one cycle of y equals sine x. But you will not just graph one cycle unless that's all that fits on your graph. You will continue this pattern all the way off the graph. So I will be seeing that I will be looking that you know how to do one cycle, but that you can also follow a pattern and finish. And when I evaluate and assess you, I want to see that you can follow the pattern keep going. So I'm just going to keep following this pattern since I went 0, 1, 0, negative 1, 0. Now I go to 1, then I go to 0 again, and then I ran out of graph space. So I'll put an arrow and go the other direction. It's a little bit easier on the graphs that I put on your worksheet instead of these notes. I didn't even realize I left these from last year, sorry. Those aren't the easiest ones to graph on, those at home are probably easier. So this is what I'm going to want to see when you graph a sine function, all the way off. The arrows means it goes on forever. That is the parent function for sine, and then we'll do transformations from that. Excuse me. So at the bottom, we've got cosine. So y equals cosine x. We're still going to use the same parent function x. They're going to be the easiest ones to use, but we're doing cosine. So at 0, cosine is 1. Then 0, then negative 1, then 0, then 1. So those are the highest and lowest values for cosine. So 0, 1, pi over 2 is 0, pi is negative 1, 3 pi over 2 is 0, 2 pi is 1. This is also smooth curves, just like sine was. And you will continue the pattern just like you did for sine. I should not see zigzags on your paper. If it looks like zigzags, you're not taking the time to curve it. So make sure yours don't look like zigzags. You can tell the difference. I know you can. When you're ready to go on, show me, but bring a paper. It's on. Okay. And there's way more examples in this packet than we need. So I'm going to actually skip ahead. I'm going to go all the way to number 2. A couple pages there. I've given you plenty and plenty of examples, which we're not going to work through all the way in class, but if you are struggling and would like some extra help, you could come sit down one-on-one with me and we could do more of these practices together to help you. So we're going to do graphing with transformations. We just learned the parent function, so you have those in your notes if you forget them until you have them memorized. You have them in your notes. And then we're going to answer some vocabulary about these as well. So I'm going to do this part last. Let's start with filling out the table. So I'm going to look at y equals negative sine x plus 4. So we're going to be using the sine function. So I usually like to write, this is sine x. And then until I have it memorized, I might need to think about my ordered pairs. And these values, what? They can turn out. we go straight to you? Did it like turn black first or just go straight to the blue? Alright. I should probably plug it in so it's power either. Sorry, technical difficulty. Alright, so what we want to do is you're going to be filling out the table, and the x values are just the x and y axes. Alright, and then eventually you're going to be filling out your own x values too. The y values are going to be the sign at each of these. So the sign at 0 is the y value 0. The sign at pi over 2 is 1. And then 0, then -1, then 0. They're alternating zeros and ones and -1s. It's alternating every single time. Now let's look at the transformations. Who remembers a negative sign out front, outside? What does that mean? Reflect in the x-axis. Okay, that is a vertical reflection, because that is reflecting over the x-axis, which is up and down. So it is a vertical reflection, but we write reflect in the x-axis. And then how about +4? Translate up 4 units. So these are both vertical reflections. So we're going to put those both on the y side. Since they're both on the y side, do I do multiplication or addition first? Multiplication always comes before addition, so we're going to multiply by -1 first, then add 4. Yeah, that's what it is. I'm not going to have you graph the parent function every single time. I know you're sad. We're just going to graph the new function. All right? So you don't have to worry about the previous y's. We're just graphing the x's and the most outside y's. 0, 4. Pi over 2 is 3. Pi is 4. 3 pi over 2 is 5. And 2 pi is 4. Then you will continue the pattern. After you have your one cycle, you'll continue that pattern until you've run out of graph. It should look like one smooth curve the whole time, a nice rolling wave. Should have arrows at the end that says it keeps going forever. Okay? Then we'll fill out the information, which is the vocabulary that you should be learning as well. Well, maybe it doesn't. Just you didn't have enough that looked clear. So those look like zigzag areas, slightly less zigzag. And then right in the middle, you're supposed to put the thing that's on. You see what I'm saying? Like it goes up when we do it. I'm walking around because a lot of people make mistakes when they continue the pattern, and I'm just trying to catch some mistakes early before we before we do a bunch of these. I want to make sure that there's no mistakes that are standing out big time. Remember last year when I put bad ones on them? Hopefully we don't have to do that this year. Did I put yours up there? No, I put yours as good ones, didn't I? Okay, now the period. The period is one cycle. So if you look up here, if the period is one cycle, it's like a horizontal length, all right? And the only thing that can possibly change a horizontal length would be if I did this, or I did that. Does anybody know what I'm doing transformation-wise if I do this? What kind of shrink or stretch? Horizontal shrink or stretch. Did I have a horizontal shrink or stretch? Did I have one here? It did not. So the period is just a normal period, which I said earlier was one full cycle. One big circle is how long? 2 pi. And if you look from right here at the start to the end, that is a length of 2 pi. So the only thing that would change the period would be a horizontal stretch or shrink. That's the only thing that would change our period. The amplitude. The amplitude is, on the graph, how far above or how far below this center midline the graph goes. That's what it is on the graph. Can you look at my graph and tell me how far above or below the midline it goes? 1. The amplitude is never negative. The amplitude is the vertical stretch or shrink. Amplitude is the vertical stretch or shrink. That's pretty messy. I need to write in clearer. Sorry. The sinusoidal axis. The sinusoidal axis is just the midline equation. So I just kind of drew it over here when I was talking about the period and the amplitude. So I write this is called amplitude. Amplitude. Okay. The midline equation is the sinusoidal axis. So this is a horizontal line that passes through the center of this graph. Can you tell me the equation of this sinusoidal axis? Huh? Y equals 4. Yep. And if you look, that y equals 4, that is the vertical translation. So all of these are coming from the transformation, and since we went up 4, that was up 4. Domain is left to right, all the x's, left to right. How far does this graph go to the left to the right? It's all real numbers. We're going to put it in interval notation. Negative infinity, positive infinity. Yeah? And then the range is up to down, down to up, down to up. So how low does it go and how high does it go? And does it include 3 and 5? So we will do brackets between 3 and 5. Hey, another one? Okay, let's go to number 4. I'm going to peek at something real fast before I go on. Yeah, number 4. I know how much time we have. Let's skip that. Let's go to number 5. Let's do number 5 instead. Did we just do a sign? Yeah. Trying to do something. Should we do 6 instead? We just did a sign. But we've already done one of those too. Nah, we'll do 6. It's fine. You guys have done transformations before. Let's do 6. So I look here and I see, cosine this time. So I'm down here. I'm going to go to cosine x, and I'm going to fill out my cosine values, which if you forget, the cosines are from the ordered pairs, the x values, when you go on the unit circle. So cosine's going to begin at 1, 0, negative 1, 0, 1. If they're not working, open them up and then try again. Unless somebody messed it up. So now I've got my parent function values. Now I'm going to write my transformations. What does this negative out front tell me? Reflect in the x-axis. Perfect. Reflect in the x-axis. That is a vertical. So we'll down here be multiplying by -1. I'll get there in a moment. Now this 2 comes after cosine, but it is affecting the x. There are parentheses that you can't see after the words cosine. That's around 2x. So this 2 is inside of the cosine function. So it's inside the cosine function. Is that horizontal or vertical? Horizontal. And anything horizontal is opposite of what you think. So this is 2. What are we actually doing? 1/2. So this is a horizontal what? Shrink. Horizontal shrink. By factor of 1/2. So down in my table, I will be multiplying my x's by 1/2. And then the -2. Because it is not in parentheses, I know the -2 is vertical. If it was part of the inside of the function, there would have to be parentheses for that -2, which we're not even doing today. You'll see those on the next lesson. The only ones that you won't see the parentheses would be for if the number is in front of the x. Okay, so -2 is a translate down 2 units. So we'll do -2. So down in my table, I'm going to change all my values. When you multiply pi over 2 times 1/2, we have to multiply fractions. Remember, you multiply fractions by multiplying straight across. So I get pi over 4. And then my y's, I'm going to multiply by -1, and then subtract 2. Then we will graph the outsidemost x's and the outsidemost y's. Now, some people have trouble on the graphs because there isn't a pi over 4 on your graph. But if I graph the ones that I can see, like I can definitely see where 0 and pi over 2 and pi are, I graph those. Pi over 4 has to be exactly in between 0 and pi over 2. Like these are all evenly spaced. So if you graph some of them, then you can find the middle or the points that you weren't able to locate on your graph. Because they're always evenly spaced on the x value, always evenly spaced. Once I get my first cycle graphed, then I just continue the pattern and graph the rest of it all the way off the graph. Filling out the period. The period is how long horizontally one cycle is. So I could look on my graph and count how long it is. Or the period is also normally 2 pi. And then whatever we did to the horizontal stretch or shrink, whatever we did, do the exact same thing. So if I multiply that by a half, just like I did the x values up here, then my period would be pi long. So it's the exact same thing that I did for all my x values, I do to the period. The amplitude is the vertical stretch or shrink, which there is just one. Thank you. The vertical stretch or shrink is 1, or how high above and below the midline it was. Sinusoidal axis is the midline, y equals -2. The domain is all real numbers, or negative infinity to positive infinity. And then the range goes from -3 to -1. I'm going to try to record a different example in my third bell so that you guys will have more examples if you'd like to go watch the video. But this worksheet will not be due till after we take our test, the block day. You guys will have till Thursday to do this stuff.